Welcome back. This is the last video for Unit 1B about reasoning and proof. This video today is about congruent and right angles. First, I need you to write down these three properties of congruence that also work for angles. You've already learned the reflexive, symmetric, and transitive property of equality. Now we are just applying them to congruent angles. Now we're going to learn a new theorem called the congruent supplements theorem. It says that angles supplementary to the same angle or to congruent angles are congruent. So let's break that down. The first part of this sentence, angles supplementary to the same angle or to congruent angles, the part before the verb, are. This part is the hypothesis of the statement. The conclusion of the statement is that the two angles are congruent. So in order to write this in if-then form, we could write it like this. If two angles are supplementary to the same angle or congruent angles, then they are congruent. So for example, let's say that you're given that angle 1 plus the measure of angle 2 equals 180. Basically, the angle 1 and angle 2 would be supplementary. And also, the measure of angle 2 plus the measure of angle 3 equals 180. So, aka angle 2 and angle 3 are equal to 180. They're supplementary. Then you can conclude, since angle 3 and angle 1 are both supplementary with angle 2, then angle 1 and angle 3 must be the same thing. So angle 1 and angle 3 would have to be congruent. Looking at a picture here, let's say I know angle 1 and angle 2 are supplementary. Maybe angle 1 has a measure of 60 degrees and the measure of angle 2 then is 120 degrees. Those two angles are supplementary. Now let's say I also know angle 2 and angle 3 are supplementary. So I know angle 2 plus the measure of angle 3 has to add up to 180. There's no other possibility for the measure of angle 3 other than 60 degrees. Therefore, angle 1 and angle 3 must be congruent. There's no other possibility. If they're both supplementary with angle 2, then angle 1 and angle 3 both have to be congruent. There's a similar theorem for complementary angles. It's called the congruent complements theorem. So similarly, it says angles complementary to the same angle or to congruent angles are congruent. So the hypothesis of this statement is that angles are complementary to the same angle or to congruent angles. The conclusion is that those two angles are congruent. So in if-then format, it would say if two angles are complementary to the same angle or congruent angles, then they are congruent angles. So for example, if you know that the measure of angle 4 plus the measure of angle 5 equals 90, therefore angle 4 and 5 are complementary, and you also know angle 5 plus the measure of angle 6 equals 90, so hence angle 5 and 6 are also complementary, then since angle 6 and angle 4 are both complementary with angle 5, I know angle 4 and angle 6 have to be congruent. Similar to the last example, let's say angle 4 is a 25-degree angle and angle 5 is a 65-degree angle. Angle 4 and angle 5 are complementary. They add up to 90 with their measures. Now let's also say that I know angle 5 and angle 6 are complementary. Angle 6 must be the same measure as angle 4 in order to be complementary with angle 5. So angle 6 has to be 25 degrees if it's going to be a complement to angle 5. Therefore, angle 4 and angle 6 have the same measure. They're congruent. Let's try using this in a theorem. In a proof. So it says to prove vertical angles are congruent. So if they don't give you a picture or they don't give you labels, you'll always want to draw your own picture. I went ahead and drew an example of vertical angles. It said to use angles 2 and 4 as the vertical angles. So I drew two and 4 as vertical angles. I know the definition of vertical angles from chapter 1. So I'm given that angle 2 and 4 are vertical angles, and I'm trying to prove that angle 2 is congruent to angle 4. In order to write this proof, I know that the first thing I need to write is the given statement. So I'll go ahead and write down angle 2 and angle 4 are vertical angles. I'm trying to use congruent complement or congruent supplements theorem. So let's try to come up with kind of a plan here. We know that we're trying to prove angle 2 is congruent to angle 4. So let's just go ahead and put that in at the bottom. We're not sure what reason we're going to use yet, but let's think about this. I know that I'm going to have to try to use the definition of linear pair and then say that two pairs of angles are supplementary. So let's think. I know that I want to have angle 2 and angle 4 in my answer. So I know I need to use angle 2 and angle 4. I know they're not a linear pair with each other, so I'm going to have to pick another angle to put in here. So let's look at this. Angle 2 makes a linear pair with angle 3. In addition, it makes a linear pair with angle 1. Similarly, angle 4 makes a linear pair with angle 3, and it also makes a linear pair with angle 1. In order to be able to show that angle 2 is congruent to angle 4, I'm probably going to need to show that it makes a linear pair with the same angle as angle 2. So I'm just going to choose angle 3. So I know angle 2 and angle 3 form a linear pair. And I also know that angle 3 and angle 4 form a linear pair. By choosing angle 3 both times, it helps because then I have 3 the same in both of them, but then 2 and 4 are different, and that's what I'm trying to prove they are congruent. So I know this is going to be helpful. Next, since they form a linear pair, I can say that they also are supplementary. Do you remember the name of the theorem that says if two angles form a linear pair, then they must be supplementary? Now that I know angle 2 and angle 4 are both supplementary with angle 3, I can use the congruent supplements theorem to say that angle 2 must be congruent to angle 4. Next, let's talk about the vertical angles theorem. This says that if two angles are vertical angles, then they are congruent. So from now on, instead of going through all 4 of these steps to prove that two vertical angles are congruent, you can just say vertical angles theorem tells me that they must be congruent. So for example, if you know angle 1 and angle 3 are vertical angles, you can conclude that angle 1 is congruent to angle 3. Let's use this in a proof. It says, prove that if ray DB bisects angle ADC, then angle 2 is congruent to angle 3. I highlighted the ray and the angle in the picture for you. In addition, I went over the straight lines with a black marker so that I could clearly see the vertical angles. I see that angle 1 and angle 3 are vertical angles. However, I'm trying to prove angle 2 and angle 3 are congruent. Well, what else do I know here? I also know that ray DB is a bisecting ray. Therefore, it's splitting that blue angle ADC, exactly in half. So I also know that angle 1 and angle 2 are congruent. So if I know angle 1 and 3 are congruent, and I also know 1 and 2 are congruent, I can probably use transitive property to show 2 and 3 congruent to each other. So that's my plan. Let's see if we can make it work. I know that my last step down here is going to say angle 2 is congruent to angle 3. Now let's start from the beginning. I see ray DB bisects angle ADC. So I know that means that angle 1 and angle 2 must have the same measure. That's the definition of bisect, is that it splits an angle into two angles that are equal measure. My final answer, though, is all about having congruent angles. So I'm going to go ahead and switch this to say angle 1 is congruent to angle 2. So now I have congruent and angle 2 so far. I know that I'm allowed to do that by the definition of congruent angles, because any angles that have the same measure are known to be congruent. So I know angle 1 and angle 2 are congruent so far. I have not used my vertical angles theorem yet to say angle 1 and 3 are congruent. But I'm going to put that off for a second because I see that right now I have angle 2 in the right side of my congruent statement, but in my answer I see that it has to be on the left side. So I'm going to go ahead and switch this around before I do vertical angles theorem to say angle 2 is congruent to angle 1. That's called the symmetric property of congruence. Alright, now I can go ahead and say angle 1 and angle 3 are congruent by vertical angles theorem. But let's be very thoughtful about how we write this out. If I want angle 3 to end up on the right, I should probably make sure that angle 3 is on the right now. So I could have said angle 3 is congruent to angle 1, but I want to make sure angle 3 is on the right side since that's how I see it to be in my answer. Now let's see if I can figure out how I'm going to get my conclusion. I see that angle 2 is congruent to angle 1, and angle 1 is congruent to angle 3. Remember earlier I was thinking I could probably use transitive property to show angle 2 is congruent to angle 3, and I was correct because angle 1 matches up in the middle here. So I can skip over angle 1 and just go directly from angle 2 to angle 3 by the transitive property of congruent angles. Finally, I want to go over some right angle theorems with you. The first one says perpendicular lines intersect to form 4 right angles. So for example, these lines here, L and M, intersect to form angles 1, 2, 3, and 4. Those are all 4 right angles. Next, all right angles are congruent, so any pair of right angles must be congruent. Next, perpendicular lines form congruent adjacent angles. You should know the word adjacent angles. That's a vocab word from chapter 1. It means that they share a common side but no common interior points. So for example, angle 1 and 2 are adjacent angles. They must be congruent. Another pair would be 2 and 3, etc. Next, if 2 angles are congruent and supplementary, then each is a right angle. So for example, if you were given that angle A and angle B are congruent and supplementary, hence they have a measures that add up to 180, what could you conclude? I want you to fill this conclusion in here. And finally, if you have 2 congruent angles that form a linear pair, then they must be right angles. So if you're given that angle 1 and angle 2 are congruent and they form a linear pair, you can conclude that angle 1 and angle 2 must be right angles. Think about it. The only possible way to have it form a linear pair, which means that they would have measures that add up to 180, and be equal is if they were both 90 degrees. 90 plus 90 equals 180. Finally, for the reflection question today, please describe a mistake or a misconception that you had during this unit. What did you learn from that mistake or misconception? Please explain your answer in 2 to 3 complete sentences. That's the end of this unit, Unit 1B, Chapter 2, all about reasoning and proof. If you have questions, please reach out.